Telescopes just keep getting more and more advanced, providing scientists with a lot of new information. In today's video, we'll tell you about the new telescope NASA will launch that is said to change a lot. So, let's begin. This telescope is called the Nancy Grace Roman Telescope. The Nancy Grace Roman Space Telescope, also called Roman or the Roman Space Telescope, is an infrared space telescope that is being made by NASA and will be launched in May 2027. In 2010, the committee that did the Decadal Survey for the US National Research Council decided that Roman astronomy should be the top priority for the next 10 years. On February 17, 2016, WFIRST got the go-ahead to start making plans for its launch. In addition to measuring the effects of dark energy, the consistency of general relativity, and the curvature of spacetime, this telescope wants to use gravitational microlensing to look for planets outside of our solar system. It also wants to find out how long the universe has been around and how cosmic structures have grown. The main goal of this telescope is to figure out how curved spacetime is. It will help the European Space Agency's EUCLID mission by answering some of the most important questions about dark energy, ESA. Here are some of these questions. Is the universe moving faster because of a new source of energy or because general relativity doesn't work on cosmological scales? If a new energy component is the problem, does its energy density stay the same in space and time, or has it changed over the history of the universe? Roman will use three methods to look into dark energy on his own: baryon acoustic oscillations, studies of supernovae far away, and weak gravitational lensing. The Roman Space Telescope will look into the mysteries of dark matter and dark energy in many different ways. It will do large-scale surveys of galaxies and groups of galaxies, so that the effects of dark matter and energy on the shapes and locations of galaxies and groups of galaxies across the universe can be studied. The total number of galaxies seen will be more than 1 billion. In addition, it'll look at Type 1a supernovae that are very, very far away in order to use them as a way to track down how fast the universe is growing. This will give us a different way to figure out what dark energy is. Because of this discovery, we're going to learn a lot more about dark matter and dark energy. The Roman Space Telescope will also study exoplanets using two different methods: microlensing and a technology demonstration using a coronagraph. In order to learn more about the phenomenon of microlensing, the mission will look toward the center of our Milky Way galaxy, where there are a lot of stars. The coronagraph equipment will show new ways to take direct pictures of exoplanets and the disks that surround nearby stars. Taking account of exoplanets will help answer new questions about whether or not there is life elsewhere in the universe. What kinds of planets can be found in the coldest parts of planetary systems that are the farthest away? What makes it possible for life to exist on a planet or planets like Earth? Gravitational microlensing is being used for this census because it can find extrasolar planets with masses as small as a few times that of the Moon. The census would also include a sample of free-floating planets whose masses might be less than that of Mars. It'll add a mode called Guest Investigator, which will let people do surveys to find answers to many questions about our galaxy and the rest of the universe, and develop a coronagraph for direct imaging of exoplanets so that the first photos and spectra of planets around our nearest neighbors that are similar to our own big planets can be taken. The Roman Space Telescope will be built around a primary mirror with a field of view that is 2.4 meters, 7.9 feet wide. It'll also have two scientific tools inside. The Wide Field Instrument, WFI, has a camera with a resolution of 300.8 megapixels that can see in both the visible and near-infrared ranges. It gives images that are as sharp as those from the Hubble Space Telescope over a field of view that is 0.2 square degrees, which is 100 times larger than the field of view of the imaging cameras on the Hubble. The coronagraphic instrument, CGI, is a camera and spectrometer with a small field of view and high contrast. It can measure wavelengths in the visible and near-infrared range and has a special way of blocking out starlight. NASA chose a diverse team from Ball Aerospace to design and develop the Wide Field Instrument, WFI, optomechanical assembly that will be used for the Roman Space Telescope mission. Together with NASA, Ball will help with the assembly, integration, and testing of WFI's optical and mechanical parts. The optical mechanical assembly, which is made up of the optical bench, the thermal control system, the precision mechanisms, the optics, the electronic parts, and the relative calibration system, provides the stable structure and temperature environment that makes it possible to observe WFI in a wide field and with high quality. The relative calibration system is another part of the optical mechanical assembly. Paul came up with a way to spread out the light that comes in by using equipment that was already there. This saves money and time for the mission. Ball Aerospace is NASA's partner in science. Its instruments and spacecraft have helped scientists find new things for decades. This partnership started with the great observatories and has grown to include Webb and the Roman Space Telescope. The Roman Space Telescope will let scientists in the fields of astrophysics and planetary science do a lot of different kinds of research. In addition to the survey programs that are already being used to study dark energy and exoplanets, these probes will be sent out. It'll have a strong general observer program that'll let scientists study things like solar system objects, exoplanet transits, brown dwarfs and stellar remnants, stellar populations of the Milky Way and nearby galaxies, galaxy evolution, quasar, gravitational lenses, and the sources of re-ionization. This program will give scientists the chance to study things like exoplanet transits, brown dwarfs, and the remains of stars. In honor of the former NASA chief astronomer's contributions to the field of astronomy, NASA Administrator Jim Bridenstine announced on May 20, 2020, that the project would be called the Nancy Grace Roman Space Telescope in her honor. On September 29, 2021, NASA said that Roman had passed its Critical Design Review, CDR. Taking into account the effects that COVID-19 is expected to have, they also said that the launch wouldn't happen later than May 2027. Under the terms of a contract, Roman will be ready by October 2026. It'll be launched on a Falcon Heavy rocket in May 2027 to help NASA meet a launch commitment. The Giant Magellan Telescope is another thing we have. The most powerful telescope ever made is the Giant Magellan Telescope, GMT. The building of it has been going on at a snail's pace lately. It got an extra $205 million in funding to speed up this process. The Great Magellan Telescope Organization, GMTO, says that this investment is one of the largest rounds of funding for the telescope since it was first made. With the money, a huge 12-story telescope building will be built at the Las Campanas Observatory in the Atacama Desert of Chile. Once it's up and running, the GMT will be 4 times more powerful than the James Webb Space Telescope because it'll be able to gather more light. It'll also be 200 times more powerful than any other telescope used for research right now. Even though there's no set date for completion, commissioning is expected to start in the late 2020s. This latest cash infusion will help make this goal a reality. Many people think that the Giant Magellan Telescope is the next step in exploring space. It'll use the biggest mirrors in the world, a 25.4-meter matrix of 7 8.4-meter diameter mirrors that weighs 18 tons. The total light-gathering area of 368 square meters will give clear images from nearly 160 kilometers away, making it possible to see small details on the coin. With these features, it'll be possible to make images of the universe that are even more detailed than those made by the James Webb Space Telescope, whose most detailed images recently shocked the world. Undoubtedly, the world of technology keeps on evolving, and we'll see a lot of developments in the future. That's it for today, guys. Hope you enjoyed the video. Leave a like and comment down your thoughts on these telescopes. And don't forget to subscribe to the channel. Thank you for watching.